Let's start by introducing Dr. Himanshu. He leads the AI and Cyber Center of Excellence at Applied Research, an electrical and computer engineering researcher focusing on AI and cybersecurity, teaching various courses in those areas. And he's going to start by kicking things off, talking about large language models and all of the various things that they can do nowadays. So.
Thank you. All right, good afternoon, everyone. So my talk is split into like three parts. First, I will go over some fundamentals of large language model. Today morning, you heard from the keynote speaker. This is an emerging technology, so I'm going to introduce the concepts. Then I'll talk about how this is being used. We have a prototype that we have developed, and then actually I'll try to do a demo if possible here. So first acknowledgement, this research is actually funded by Director of Operation Test and Evaluation. And we're working with ECI at Florida International University, where we are building the proof of concept of this large language model. We have also set up an AI Center of Excellence at FIU, supporting DOT&E with the cutting edge research that some part of that you'll be seeing it today here. So a little bit about FIU. Florida International University is based in Miami, Florida. It is one of the largest Hispanic serving institution in continental US. It is one of the 10 largest public universities with more than 55,000 students as of 2023. Top tier research institution, R1 Carnegie classification that FIU holds actually. And we award maximum bachelor's and master's degree in for the Hispanic students. And it has a designation of minority serving institution. So before we start going to the large language model, I just wanted to give you kind of a brief about different terminologies that are used actually, and they are used interchangeably. But I want to just clarify the basic differences between the terminology used in AI, machine learning, deep learning, and now the fourth technology that's generative AI is a topic of discussion today. So AI is a broad field, and it has been there for years, like from 1950s and 60s, where basically every effort is made to develop computer systems so that they can behave, act, and like human intelligence. So AI has multiple fields, like a group of algorithms, you can say, in like search, then knowledge inferencing, optimization, and now the field of machine learning, deep learning, and generative AI. So machine learning is again a specialized area of artificial intelligence when we are looking at a bunch of algorithms where we are not doing any programming, but the algorithms or the models, they are actually learning from the data that they are exposed to. And so you can see ML is a subset of AI, and the deep learning is again a subset of machine learning. So there is only one kind of algorithm, that's neural network, that's actually comes in machine learning, but it has grown up so much that it has its own field, and it is referred to as deep learning based on artificial neural network. And so ANN, or the deep neural networks, actually now has multiple variants and has multiple applications in different domains. And that's how this new field has come up here. So now coming to the generative AI, as you can see here, is again a subset of deep learning, and which is now actually very popular. And it was introduced in 2017. The concept was introduced, but now it has become very popular because of the ChatGPT. And there was a lot of research conducted from 2017 to 2023, where the system, the ChatGPT platform, and now the Gemini from Google, they have all become like, those models have become the platform actually, and they are providing a lot of capabilities which are very human-like. So I am working with especially machine learning since 2016, working with Department of Defense Test Resource Management Center. And now the research is funded by DOT&E here. And we have seen that machine learning has done a lot, is really the models that have built in the machine learning domain, which we call it now classical machine learning. They have given fantastic results in the cybersecurity applications. Now, once we looked at the deep learning that came out from machine learning, again, the results were fantastic there. But the generative AI is a game changer, actually. So, and I can show you like how this is becoming more creative and solving different problems. And the algorithm that are evolving, and now the commercial world and the open source world is kind of revolutionizing this technology. And I think Gen AI is going to be the future, irrespective of the domains where it is being used. It has human creativity to produce novel, coherent, and contextual outputs, actually. Enables machines to understand patterns and generate complex data autonomously. And because of these capabilities, you will see that the Gen AI is going to be extremely popular and used in the field. So one distinction I want to make here between the machine learning and the deep learning or generative AI, machine learning is very focused on the structured data. What I mean by that, like tabular data, something in the Excel format, or if you're familiar with relational database management systems like SQL Server or Oracle. So classical machine learning is doing very good job in those areas. But when the data becomes unstructured, that's where the neural network came into picture. And they were implemented, whether it is text data or it is image data, actually. So you will see two classes of applications that are evolving with deep learning and the generative AI, which is focused on unstructured data here. And why they are becoming very popular? Because if you look at machine learning fundamentals, in order to build your model, you need some attributes and features, actually. So if you have the structured data, you have attributes, rows and columns. So with the columns, you are able to model your problem. But when you come to text or when you come to images, it is extremely difficult to define those features, because in image, every pixel is your feature, actually. And whatever the size of your image, if you just multiply the length and the width, those many attributes or features are going to be there, which is humanly impossible to build that. But the deep learning algorithms and especially the neural network algorithm allows you to automatically extract those features, actually, and build your model. And that's why this technology is actually growing at a rapid pace. So these are some of the algorithms. If you are familiar with deep learning, CNN, which is convolutional neural network, RNN is actually a recurrent neural network, and LSTM is one type of RNN network that is used for, let's say, 10 years or so, and they were doing pretty well now before the generative AI came into picture. So CNNs can understand local feature, the automatic feature extraction, which I talked about, which is a very labor-intensive process, and humanly it is impossible to define all those pixel and values. When you come to text analytics, actually, every word or a part of your word becomes your feature. And if you have a document with, let's say, 200 pages, it's impossible for a human to go and actually identify those features and then encode those features. So neural networks allows you to do automatically. And that was the case with the RNN, LSTM, and the CNN when it comes to the image classifications. However, the challenge with these LSTM algorithms was the sequence, the length of the sequence. So let's say if you take a sentence and you try to model that sentence, it has a problem of something called vanishing gradients, actually. So what happens, they have to remember, as a human, we will understand the sentence and we can interpret those things. But for algorithm to understand, it has to remember what was mentioned previously. And as the length of the statement becomes bigger, LSTM were not able to perform that good. Or many variants of LSTMs were available. They were not actually doing good job. And so all these things, different algorithms for a short length, they work pretty well. But for the longer length or the paragraph kind of scenarios, they were not giving the results that great. The other challenge that was there, that they are sequential. So like a time series, actually, but now you are treating these sentences as the time series data where you are establishing the sequence, and they are going one after another. So it used to take a lot of time when you are trying to train these models, whether it is a CNN model or the LSTM model. So in 2017, actually, the Google came out with this paper, which you see, attention is all you need. So this is the research outcome of the Google, and they published this paper. And there was a new algorithm that was implemented called transformers. So the entire LLMs that you see here, which is very, very, of course, Google could not monetize that this algorithm to a great extent, which actually Microsoft, along with OpenAI, they did the phenomenal job of building that ChatGPT platform on the same algorithm, which was actually developed by Google here. On the right side is a pretty complex train. It's kind of an encoder and decoder scenario where you are encoding a particular text and then you are decoding that. So that was one observation, but it is similar to LSTM. However, now it allows you to parallelize that. So this algorithm was implemented with 6 series that were implemented in parallel. So the performance of these models, that they have really improved. And now you have many variants of transformer algorithms, which is called encoder or encoder decoder. So the ChatGPT model that you see, which is trained on millions and millions of documents from the internet or the web, they are actually implementing the decoder version of the transformer model. And so the reason it has now improved the performance, and it is able to handle the long sequence, which was difficult with the deep learning algorithms actually. So now you can see the use cases, generative AI use cases used in image generation, audio generation, text generation, and finally the code generation. So the coding community actually is so happy with this because you are able to generate a lot of SQL statements or Python programming or C# programming or Java programs with the help of ChatGPT. And so this particular model, the ChatGPT or the Gemini, and now you will see every day new models are being implemented and deployed on Hugging Face, where they are trained for a specific problem set. So you can see these applications which I'm addressing here, 4 applications. The text one is very, very popular because of the platform that you are familiar with, but the image generation also is catching up actually. So there is a lot of research going in the image generation as well as the text generation. However, today's topic is more focused on the large language model, which is text generation algorithm. So then what are LLMs actually? So the LLMs are the Gen AI systems capable of understanding and generating human-like text, and everybody is using it from the vast data on which it is actually trained. So, and they have extracted all the data from the web, and that's how the model is trained. What's the challenge here? These models are very expensive to build because they need lot of GPU power and multiple cores there. And it takes a long time to train these models. So it is very expensive to do that. And the complexity of the model in terms of, we call it something called weights, which are the parameters of these model. And so it ranges from like few billions to 300, 400 billion parameters. So if you are familiar, like we have seen a lot of presentation when you have a best fit line and you have y is equal to f of x. In simple terms, x is your input and y is your output. And so if you have equation of a line, which is y is equal to wx plus b, there is only one feature x, and you're trying to learn that function f actually. So that relationship, that wx plus b, those w and b are actually the parameters of your model. So like that, in this equation of a line, you have 2 parameters. But when you go to these large language models, you have 400, 500 billion parameters on which it is to be trained. So you need GPUs that can run in parallel and then build the model and then ultimately identify those weights. So our effort here in this research was, instead of going to the web, can we bring those models in-house? So we chose like small models there with 7 billion parameters or 12 billion parameters, and we were able to run on the GPUs in-house so that we can train the model on the data that cannot go on the web. So that was the more focus of this particular research here. So once the next step is actually to understand how these models are trained. So there are different ways that you can use the model. you can use straight away a pre-trained models, which is basically you do it on the web actually. So that's one of the approaches. The other one that was talked this morning also was prompt engineering. And so there is some different kinds of learning that is possible. And the three that I am listing here is a zero-shot learning, one-shot learning. So let's say if you are going and asking a question to the ChatGPT, you are not giving any examples. So that's an example of a zero-shot learning where the prediction is made by the model, but no input is provided by the user actually. When we say one-shot learning, in that case, you are giving one example to the model that I am looking for an answer in this particular way, then it is termed as one-shot learning. And when you say few-shot learning, means you are giving 4 to 5 examples to the model that this is how I want you to generate the response. And then, so model basically looks at that input and automatically generates the output mapping to your input. So this is one way of kind of getting the answers from your from the model by using zero-shot, one-shot, or few-shot learning. So, and this also comes under something called prompt engineering. That is the technique of crafting prompts to effectively guide the model in generating desired outputs. So as generative AI is a new field that's coming up, you will see that a lot of technologies and or the techniques are coming around that. And this is, so the one shot, few shot, or zero shot I was talking about, those are different types of prompts that you can feed to your model and you can get the response from there. The other approach, so this is all the things that I just mentioned is for the pre-trained model, that the model that is already built and you are trying to give input to the model so that you get a response that you're looking for. The other approach is fine-tune the model, which is a very difficult job actually. And so here the fine-tuning with LoRa, which is low-rank adaptation, which allows efficiently to update the small part of the weights of the model. So if you are familiar with the neural network, at every stage of the nodes, you will have weights associated with those nodes actually. And what we do here in this case, 80 to 90% of the architecture is used from the default, and we will just fine tune towards the end actually. And so by modifying those parameters based on the problem that you are trying to solve, which can be a domain specific problem, or we call it a small language model for that matter. So you can use that approach also to train your model and get the responses based on the data that you are trying to train the model with. But this is a difficult job. It is not that easy to fine tune the model and make sure that it is able to handle the data that you are training on. And then the last one is the reinforcement learning. Actually, reinforcement learning is a group of algorithms that is normally used in the self-driving cars. And so that is also being used here, that the models are being trained with human feedback. So we call it RLHF. This approach integrates into training process, refining the model's behavior throughout the direct feedback. So as you can see, prompt engineering, fine-tuning, reinforcement learning with human feedback, these are all emerging technologies or approaches that we want these models to be trained so that we are able to achieve whatever our objectives are. So this I'm going to actually show you. We have set up an FIU AI Center of Excellence here, and we have restructured based on our experience working with different projects. I am running around 12 different projects for multiple federal agencies. So we have categorized on machine learning, deep learning. Those are the two areas where whatever problems we are solving, we are linking. We are going to link actually with these models. And Automaton is a data intelligence platform that is developed by Dr. Warner. So we are going to make that available. Awesome is automating the machine learning model development and prediction. And the bottom one, generative AI, is the one that's basically split into two parts: generative AI for text and generative AI for images. And of course, we are also looking to the Spark framework basically to process this data in the real time so that we can enhance the performance of model development. And of course, in the bottom, we just conducted AI workshop here that was attended by more than 110 DOT professionals at FIU in Miami. And we are planning to host a AI hackathon in the month of June, last week of June, actually. And the last part is, of course, we are a university, so workforce development is our key. And so we hire the students who work on these projects, and I will try to demonstrate those projects here, developed by all the students working in different areas of generative AI and machine learning. So this actually, okay, so one second, I just wanted to show you about the different like model development, what ML service and ML op means. So basically, we have built an automated system, advanced automated machine learning system that is targeted for the domain experts, actually. The subject matter experts who have a knowledge of data, but they are not familiar with stats or Python programming or algorithms from computer science, but they should be able to build the model to solve their problem. So that's where the model development comes into picture. And that was a traditional approach. But now with the generative AI, the model itself is becoming a platform like ChatGPT I talked about. And so everywhere, whether it is machine learning or deep learning, you will see that so model development is one part of the equation. But once you build the model and validate your model, then how are you going to do the prediction? Once you do the prediction, these models can be offered as a service. So these are the REST APIs that you can connect to these models and then solve your problem. And the last part is ML ops, which is basically machine learning operations. So how it is put in the production environment so that the users can make use of it. So everywhere there is machine learning, deep learning, or generative AI. So when we talk about ChatGPT, that's basically the Gen AI operation where OpenAI is providing users to kind of access their system. Okay, so this is a homepage of the AI Ops. I'll try to do a quick demo of this one as we move forward. But on the left, you can see we have generative AI for document summarization, chat, as well as the Q&A. But this is not the one that is on the ChatGPT, but it is an in-house model that we have trained using the nuclear data that we own while working with Department of Energy Office of Environmental Management for nuclear decommissioning, waste processing, and the soil and groundwater for the nuclear industry. And so I'm going to skip in the interest of time. I'll try to show you the demo. And this shows you the document summarizer. So this is like 30, 40 page PDF documents. And so what we did, we downloaded the model in-house on premise. And then we took this data from here and trained the model on that. So we took different approaches like prompt engineering we were talking about. So prompt engineering allows us to kind of build the prompt, sophisticated prompts using this content, and then feed it to the model so that it generates the summarization, benefits, and limitations from here. So for that document, the summary will come like this, actually. So you have a small description, what are the benefits and the limitations of this particular document or this particular technology. It gets all summarized here. 40-page document summarized into one page here. It is mobile friendly also. You can use on the mobile device, same content in the mobile device as well. This is chatbot. Of course, it's a prototype, as I mentioned, proof of concept here. So we have only 1024 tokens. Tokens means the number of words that we can upload here. And you can enter a question at the bottom. And you can see here, are there any methods to decontaminate the metal beds of trucks? And number all of them. So like this, the comment has gone. So this is like something you're used to on the ChatGPT. So this is the prompt that you are building. And automatically we train this model on like 700 documents, nuclear decommissioning documents, and you get a response like that. So then the next question we are asking, give us a numbered list of robots actually, and tell me more about two different ones listed here. Are there any limitations? So it is going to generate, it will first list you 10 robots, and then from there, it will pick the two and it will give you the advantages and the benefits of that. And this one is actually, I'm looking for information on the vacuum cleaners. So this kind of information, and then of course you can read about that and then it gives you the response. But the idea here is in those 700 documents, this information is buried somewhere, which we don't know. You'll have to go through those documents to find out. And now those things are possible with the help of this prompt engineering as well as the model. And we have used okay. So other thing I wanted to share with you is how do you get these models and train them actually? So we experimented with multiple models for document summarization, like T5 model. There are 4 variants of T5 model we use there. Then Facebook has an open source model called Llama 2. So we use Llama 2 also. And so these are the models. So like that, the research goes, like keep downloading the models, experiment where it works. And then the one that is doing great on a particular data set is the one that you're going to deploy here. And of course, these are some ethical and societal impact on that. So, I mean, I'll just skip on that. Let me see if I can show you here a quick. So when I was talking about, I'm basically here, either the firewall is blocking my request actually from the connection. So I have connected with my cell phone, and hopefully we should be able to run that. So let's say I'm selecting a particular file here. And this is actually a technology file that I have downloaded for the demonstration purpose with the slow internet connection. So hopefully it goes up and gets the response. So I'm uploading a file from this machine to my server where the model is deployed, and it is generating in the real time the summary, the benefits and the limitations, and pushing it back here. So this is an example of especially the Gen AI operation here, where you are able to get the description, benefits, and the limitation. This was a manual process. The students used to go through these documents and generate generate this kind of content and then save it in the database. I'll just show you in a second, but let me run a ChatGPT also here. So this is again on the nuclear decommissioning information which we have trained. So we can just say hello. And then say, hello, you are familiar with the chat that you are used to with the customer service. And let me see. Are there any methods for so then it will give you like, now this thing is sitting somewhere in that documents, and it is pulling the answers from there. So one quickly, last thing I just wanted to show you in the interest of time. List 10 robot. So it will start listing you 10 robot technologies. You can say 5, it will list 5. So the bottom line is this is really, where you have a lot of text of the content. I'm just showing you a few examples here. These are small language models or the domain specific models in-house that you can build like this and provide solution here. And the source for this system, So this is actually a knowledge management system that we have built for DOE EM, Office of Environmental Management. We do work with multiple national labs. And so we have collected all this information. So this was readily available actually. So when we started working with DOT&E, we just took this nuclear data and we started training, and it's a labeled data here. So that's why that's one of the challenge to generate labeled data. And so we had that, so that really helped us in building this generative AI or LLMs actually for that matter. We do have examples for image processing. Similarly, there are multiple algorithms that are available for each one of them. So with that, I'll stop. I have a lot of things to show, but we don't have time. So if there are any questions, I'll be happy to answer.
Another question.
How much variation do you get when you ask the same question?
Lot of, because one of creative, and you heard the term hallucination in the morning. So there is a parameter called temperature. So if you keep the temperature low, you will have a very deterministic response. But if you try to make it like to the maximum value, whatever the range is, then it is going to hallucinate and it will become very creative and it will give you responses. So definitely as humans, you may not reproduce the things exactly the same behavior you will see here as well. Question.
Yeah, I assume you built RAG into it at all?
Yes, this is RAG. What you're seeing is RAG with a Llama 2.
Okay, so is it giving sources? Like, I'm curious if what success you've seen with it providing sources and being tracked back to the original doc and looking at it.
Yeah, no. So we haven't gone back to that, but but once it gives out, like for example, it is showing 10 robotics technologies. So we will do a search on the knowledge management system and look at those 10 technologies that are out there.
And then have you done true benchmarking on that?
No, this is just this is like what, say 6-7 months of research here.
Yeah.
So at this stage, we are trying to bring multiple models, as I mentioned, right? We use 4 models from TPI, then we use 2 of the llamas, and we are evaluating the performance of each one of them. So one of the challenge was, can we generate the summarization benefits and limitation? So we got good success there, and it was observed that the quality of the description of the technology we have in the system, this was doing much better than that.
Okay.
Very good result from these models, actually. Absolutely.
Thank you very much.